Hi, I'm Max, and today I'm going to be talking about motion in a circle. Circular motion is very important in physics as it's used in a lot of different areas, like inside the atom, and especially in things like galaxies in the universe, and basically everything to do with space. Because obviously, like planets move in like circular orbits, and you need to know their uh, angular velocities, angular momentum, and things like that. And today I'm going to take you into a brief overview of that. So, first of all, you may or may not have heard of radians before, but basically it's like another form of degrees, and instead of using 360 degrees, we're using 2 pi instead. This is because it's known as like the arc length in a unit circle. So as you go around a circle of radius 1, you should cover a distance of 2 pi, and this basically makes it a lot easier when we talk about distances. So first of all, we have our arc length here, and that you can basically think of as a multiplication of the fraction of the circle's subtended multiplied by the total circumference. So that might be like a quarter of this circle here would be like a quarter as a fraction timed by the total circumference. And by using this 2 pi, these radians instead of 360 degrees, it actually simplifies like a lot easier. So it turns into theta r, which is a simple expression for the arc length. Remember to always look into your calculator and check that it's in radians instead of degrees, because that completely changes the answer. Because obviously we're using a scale of 2 pi instead of 360 degrees. Furthermore, this can be derived into angular velocity. So by differentiating this in terms of t, in terms of time, we can get the change in arc length over time. So this is basically the change in distance over time. Distance over time is velocity. And we also have to differentiate this theta r. So we get, and theta is the only thing that changes if you move on at a fixed distance from the radius. Theta is the only thing that changes. So since r is fixed, you don't have to differentiate that in terms of time. So all we have is d theta over dt. And d theta over dt is literally just the change in angle over time. So you can think of that as like analogous to a velocity. So a change in something over time, the change in the angle over time, is known in physics as omega, this little w here. So velocity is omega times the radius. Okay, a few questions. How many radians in a fourth of a circle? So we look over here, there's 2 pi. And a fourth of the circle, we have 2 pi over 4, so that should be pi over 2. Yeah, pi over 2 radians. What are units of angular displacement and angular velocity? So, units of angular displacement, we have s, and that would be in radians or meters. Angular velocity, angular displacement is always in just in radians, because it's the change in angle. So this should be the change in angle. Angular velocity, that is as we can see here, the d theta over dt. So it's the change in radians over time. So that is per second, radians per second. 3. If a wheel spins at 15 revolutions per second, what is its angular velocity? So what you're going to want to do is find out how many radians are in those 15 revolutions. So you want to do 2 pi, because that's all the radians in one revolution, times by 15. So we'll get 2 pi times 15, and that is 30 pi. So it should be 30 pi angular velocity, 30 pi radians per second. Right. Thank you very much. Yeah, hope to see you soon.